Hi, good morning. Today I would like to present about salicylic acid in terms of toothpaste. So, the common name of salicylic acid is the salicylic acid, and for the IUPAC name, we call it as 2-hydroxybenzoic acid. For the functional group, we only have two functional groups. We have carboxylic acid, which is here, and we also alcohol group embedded here. So that's all for my part. Thank you. That's all.
Assalamualaikum, my name is Muhammad Zain, and today I will be presenting about salicylic acid formula structure. As we all know, we have five formula structure. First being is molecular formula. Second is empirical formula. Third is structural formula. Fourth is condensed formula, and fifth finally is bond line formula. Okay, for the molecular and empirical formula is C7H6O2. For the structural formula, the top of the diagram is the structural formula, and the below diagram is the condensed formula. While the second slide is the bond line formula, is where for the oxygen is unreacted electron will be shown in the diagram.
Hi guys, okay, for this part I'm gonna explain you guys about physical and chemical properties of the second chosen compound for this assignment. So as we all know, salicylic acid has the UPAC name of 2-hydroxybenzoic acid. So before we go through the properties of the compound itself, I'm just gonna reiterate some of the info that we should know that might be correlated with the property of the compound itself. So salicylic acid basically has two main functional groups, which are alcohol and carboxylic acid, that are both attached to an aromatic compound or cyclic compound with the formula of C6H5, and it has the molecular formula of C7H6O3. Next, it is colorless but mostly appear to be white in crystalline powder, which is widely used for medical treatment. It also is odorless and shows very weak solubility in water, but mostly soluble in other organic compounds such as benzene, propanol, and acetone. Next, it is an acid, hence the name, but by the pH reading, it shows the reading between 3 to 5 pH scale, and it can be very corrosive, depends on the amount of concentration of the compound itself. At room temperature, it appears as solid due to its melting point, which is around at 158.6 degrees Celsius, whereas for its boiling point is around at 200 degrees Celsius. And lastly, the density of this compound is about 1.443 gram per centimeter cubic.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nasir, and I'm going to talk about the application for salicylic acid, which is known as keratolytic as a peeling agent. This compound causes shedding of the outer layer of skin and used in treatment of acne, dandruff, seborrhea, and also to remove corns, calluses, and warts. Thank you.
Assalamualaikum, my name is Muhammad Imran, and I will be discussing about the synthesis of salicylic acid. I will be providing my slide in the next few minutes, which we'll be discussing in this video. So, how to form salicylic acid? There are three ways to form salicylic acid, which are through biosynthesis, Kolbe-Schmidt reaction with acidification, and the last part is hydrolysis of aspirin. So firstly, what is biosynthesis? Biosynthesis is a process where a compound will be modified, converted and combined into a larger or a more complex compound or a complex macromolecule in a living organism. This process requires catalyst. So, to form salicylic acid, we can obtain it from phenylalanine through biosynthesis. So, this is the structure of phenylalanine. This is a process to form salicylic acid from the phenylalanine. For the second reaction, which is Kolbe-Schmidt reaction and acidification, phenol will be react with carbon dioxide and sodium in a very high pressure, which is 100 atm, and a very high temperature, which is 390 Kelvin. The product will be acidified with sulfuric acid, and then we can obtain salicylic acid. The last part will be hydrolysis of aspirin. So we can obtain salicylic acid through hydrolysis of aspirin. Hydrolysis of aspirin will produce two compounds, which are acetic acid and salicylic acid.
Hi, Assalamualaikum. My name is Warna Jawarushda. Now my part, I will explain about reaction of salicylic acid. So, this is several type reaction of salicylic acid. Firstly, reaction of salicylic acid with acetic acid. Secondly is reaction of salicylic acid with bromine water. Thirdly is reaction of salicylic acid with methanol. And lastly, reaction of salicylic acid with acetic anhydride. Okay, move to reaction of salicylic acid with acetic acid. Okay, reaction of salicylic acid with acetic acid catalyzed by acid can form aspirin. However, this reaction is reversible and after attaining equilibrium may reverse, leading to hydrolysis of ester. So you can see the reaction of salicylic acid with acetic acid. It will form aspirin. Okay, so we move to reaction of salicylic acid with bromine water. Okay, as you can see here, this is a mechanism reaction of salicylic acid with bromine water. Okay, so basically, initially we have bromination at the carbon bearing at COOH group, and this is followed by decarboxylation to give O-bromophenol. Phenols being highly activating group undergo bromination at all three available positions, giving 2,4,6,3-bromophenol here. We start from here, and then this is the final product. It will give a 2,4,6,3-bromophenol. Okay, so next we move to reaction of salicylic acid with methanol. Okay, as you can see here, this is salicylic acid react with methanol, and it will form methyl salicylate, or as we know as oil of wintergreen. Okay, when a salicylic acid react with methanol, it will form methyl salicylate. Basically, this compound has a family odor, is used as a flavoring agent and rubbing ointments. Okay, and then lastly we move to reaction of salicylic acid with acetic anhydride. Okay, this is a mechanism reaction of salicylic acid with acetyl anhydride. When salicylic acid react with acetic anhydride, it will form acetyl salicylic acid or aspirin and acetic acid. Okay, when salicylic acid is treated with acetic anhydride, the product will form acetyl salicylic acid or aspirin and acetic acid, as you can show here. time we meet again at the second compound that our group had choose, which is propyl hexanoate. Okay, as you can see here, this is a skeletal structural formula of propyl hexanoate. The IUPAC name is propyl hexanoate. The common group is ester, and the functional group is alkoxy. Basically, this is ester, which is C double bond O O C. This is ester. Ester is derived from carboxylic acid and alcohol.
So the molecular formula for propyl hexanoate is C9H13 and O2. This will be the same for the empirical formula. So this is the structural formula, and this is the condensed formula for propyl hexanoate.
So, physical and chemical properties of propyl hexanoate. The molecular weight, it consists of 158.201 gram per mole. The melting point is negative 69 degrees centigrade, while the physical description is on the liquid state, while the last, the charge is equal to 0, which is natural.
Hi guys, okay, for this part I'm gonna explain you guys about the application of propyl hexanoate. So before we begin, I'm gonna emphasize you guys about some of the info that we should know before we begin the application process. So propyl hexanoate is also known as propyl caproate, and it is formed by the reaction of propanol, which came from the functional group of alcohol, and hexanoic acid, which came from the carboxylic acid, through the process we call esterification. And this chosen ester is releasing some sort of odor, which is famously described as that of plenty of fruits. So to specify this sense of fruit, it is famously described as sense of blackberries, pineapple, cheese, or wine. And due to its replicating sense, it is widely used in perfume or food industry, as it can enhance the flavor or the sense of the fruits itself. We also can find propyl hexanoate mostly in alcoholic beverages, due to its strong resemblance sense of plenty of fruits. And lastly, it's also used as the solvent for polar organic compound. Okay, that's all.
Assalamualaikum warahmatullahi wabarakatuh. Today I want to talk about synthesis of propyl hexanoate, which is a mixture of propanol and hexanoic acid. So firstly, propanol will release OH, which will bond with H and form H2O, and also excess of propyl group will bond with carbonic acid and form propyl hexanoate.
For the hydrolysis reaction, the process will require water. The product will be produced, which are propanol and hexanoic acid. For the second reaction is the reduction. It will require lithium aluminum hydride into the compound. The product for the reduction reaction will be primary propanol and primary hexanol.